Hello everyone, welcome to the Python conference. The topic of this session is building a production-ready search engine using Python and Elasticsearch. I would like to introduce you to our speaker of this session, Harshit Prasad. Harshit is a software engineer at Grofers, India's largest online grocery shopping platform. Hello, Harshit. Are you ready for your presentation?
Hi. Yeah,
Yes.
absolutely. I'm ready for the presentation.
Great.
Thank you, Valerie, for having me here. Uh, we can start.
Yeah, okay.
Hi, everyone. Welcome to PyCon Sweden 2020. Today, I will be speaking on building production-ready search using Python and Elasticsearch. So, one of the common actions we perform when we visit a website is search, like whether you go on a news-related website or a shopping website, or it can be anything, whether it's an e-commerce website or a video streaming platform. Search always plays a major role in business. Elasticsearch is one of the famous service built over the Apache Lucene and powers up the search in numerous applications. Python is an excellent language and to write production-ready search in less time. This talk will be around basic to intermediate talk. Those who are familiar with it, they may get some good insights from this talk, and those who are not familiar with it, and here all the new terms are these terms are completely new to them. This will surely provide some great learnings to you all. So let's begin with the talk. So a bit about me. I'm a software engineer at Grofers. Grofers is India's largest e-grocery platform. Also, I have done my bachelor's in electronics and communication engineering from LNM Jaipur. I am a recent graduate. I have graduated in this year only. Okay. In the past, I have been two times Google Summer of Code, where I worked with open source organizations like FOSS and CERN. Yeah. So in this talk, I will be covering these topics. So let's talk about what will be the overview of my talk. I will be first discussing about the problem statement and where Elasticsearch comes into the picture as a solution. Then I will be discussing about the workflow, which will be really easy to understand how things are connected with each other. Afterwards, I will discuss about the strategies to keep your production database in sync with the Elasticsearch cluster. Then we will take a look into role of analyzing tokenizers in search with some Pythonic code. And at the last, I will be covering how we can boost our search results and retrieve search results from Elasticsearch. By boosting, I mean, suppose if we have some product and we want it specifically boost it, how we can do that. So I will be covering this one in the end and how internally data is being processed by the Elasticsearch and how it's being handled will be also covered as well. Okay. Now the problem statement comes here is, can we directly use relational database to implement search feature? So see, uh, yes, we can, but there are disadvantages of it. The like there are number of network calls being made to the database can increase the load on the database and which may result in increasing the latency between the client and the backend systems. Also, it does not provide us a proper solution for scalability also. Also, it does not provide features like full text search suggestions, etc. So, so for our problem statement here, why Elasticsearch can be helpful. So, Elasticsearch is a search engine that provides search features to personalize the search experience. We just need to modify its way of working according to the business requirements. Features like full text search suggestions, term is misspelled, relevance scoring are not available in the standard relational databases. So implementing such features means investing more time and resources from engineering side. If we go for a solution to implement a search feature using relational database. So Elasticsearch provides us a benefit over relational database in such terms. Also, it provides vertical scaling, like you can increase the RAM in the CPU of the machine on which the Elasticsearch is running, and horizontal scaling as well, where you can increase the number of nodes and shards within the Elasticsearch cluster. Okay, so now this is the workflow of our search, uh, personalized search basically. So let me just go through by component. So we have our production database, and it is going through X, then Elasticsearch, and then Kibana, and then client. So X can be our like log stash or bulk indexing. This X block will be helping us to keep the data sync with our production database with the Elasticsearch in real time. So in real time, by I mean like we can implement a cron job to keep the data in sync, which can do indexing at least every day or once in a week, depending on the use case. I will be using the Kibana to visualize the working of the analyzers and tokenizers, scoring, etc., to help you folks to understand how internally things are working in search. Okay, so I will be discussing in the next slide about when both log stash and bulk indexing is used. Yeah. So strategies for syncing of data. Data from relational database can be made in sync with Elasticsearch by following ways, like we can use logstash tool plus automation, or we can use bulk indexing plus automation. Uh, so let me brief you a little bit about these things. Like logstash is an open source tool for collecting and parsing data, mostly used for collecting logs. Uh, Also logs, but we can also use it for like dumping the data from the database to the Elasticsearch. Using Logstash tool for directly sending data from database to Elasticsearch uh, might be like not much useful, which I will cover in the next slide. What's the reason regarding it? Uh, Also, regarding the bulk indexing, it's a feature which is provided by the Elasticsearch to index data in bulk form. So let's discuss these two things. So as you can see, so Logstash has its configuration file where I can input from where the data has to be feeded, and the output where the data has to be dumped. So as you can see, I am using a JDBC driver. So locally I was using Postgres database, and using the JDBC driver, I was just collecting all the data from my products table. Products table is my table which contains information related to my products. Then I am dumping all this to the Elasticsearch, where I have defined the host, index, documents, how should the document ID should be there, etc. So this is pretty straightforward and easy one. So yeah, so the reason why Logstash is not useful for our use case, it is because I will show you the mappings which are automatically created by the Logstash. You can get a more idea why it's really bad for us. So as you can see, data indexing using Logstash, what I am doing is, as you can see the table structure. So Logstash is creating mapping according to my table columns. You can observe that all the columns like product ID, product name, category, price, columns are indexed as fields in the Elasticsearch document. So yeah, pretty much that's it. So now this was pretty much about the Logstash. So our use, since we are implementing search, so we want our data to be in a more organized manner, and it should be like really and in a simple way, like in completely simply organized way, our data should be. so that everyone can understand what's happening inside the Elasticsearch and how we can improve or implement the search feature. So this is how data indexing is happening using bulk indexing. So suppose like in bulk indexing, what we are doing is like we are aggregating data from different tables. So bulk indexing, basically what happens is like it can be helpful when we want to create mappings from different database tables. So suppose we want to aggregate data from different tables to meet our business requirements. Uh, so assume I have one another table by name products extra info, which contains some extra information about the products, like how much, what's the product brand, and how much the discount has been applied to that brand or being provided by the brand. Suppose we want to aggregate data from different tables. One is products table, another is product extra info. So we will use custom mappings in the Elasticsearch, and here bulk indexing comes into role. So this is an overview of the data indexing using bulk indexing of the Elasticsearch. First, we initialize Elasticsearch client. Okay. Then we are creating mappings. As you can see, these mappings will be defining our Elasticsearch index structure. Then also it defines basically how our documents will look like, how the data will be like aggregated into the documents. Then we get the process data from the database from two tables as I defined. Once mappings are defined, we perform bulk indexing. So this bulk indexing process is what it's doing. It is creating map index with the mappings and populating all the aggregated data into form of documents in the Elasticsearch. So I will explain in the next slide what I meant by aggregating data from different tables into a single document. So let's say we have another table, as I mentioned earlier, it's products extra info. So this table like as I told you, this table contains information like product brand name and how much discount is being offered by the brand on a particular product. When we will make a query to the Elasticsearch, we want to make sure that we want Elasticsearch to return document responses such that we get products information as well as the extra information within the same document. So as you can see, we have defined extra information of the product as nested mapping. So it's really easy to organize our data inside Elasticsearch according to our business requirements. Hence, bulk indexing helps us to index data according to our business requirements, and it's a really good to go thing. We should always go for bulk indexing rather than log stash, because there is a too much room for doing some customizations to our data inside the Elasticsearch. At the right snippet, you can observe that how our data is being stored in the Elasticsearch. Seems really cool now. Yeah. Now, coming to analyzers and tokenizers. So this is also an like important thing which can be helpful to power up our search. So basically, analyzers is used by Elasticsearch to analyze the text coming from the front end part, which is client side to be more precise. So suppose, uh, so let's say we have our custom filter to remove the white space from the text. Then we are using two custom analyzers to analyze the text. These two analyzers will pre-process the text internally and will fetch results from Elasticsearch. Once these custom analyzers or predefined analyzers are defined in index settings, you can proceed with the creating new index. So also, like we can create custom filters using inbuilt tokenizers provided by Elasticsearch. There are many built-in tokenizers provided by Elasticsearch. You can check the official document on their website, and these filters are like used by the analyzers to apply appropriately like apply appropriate action on the incoming query from the client side. I will explain this in the next slide using Pythonic example too, and internally how analyzers are working. So first, let's see how uh, internally analyzers are actually working in Elasticsearch. Okay, so just let me open my Kibana. Okay, now as um, you can see our index is this. In index, I have defined my filters like filter white space remove, then English stop, which removes stop words like and, the, etc. And I've uh, declared my custom analyzers like analyzer keyword lowercase, analyzer move white space, analyzer move stop words, and which these analyzers are using such filters. Like you can see the white space removal is using the filter of white space removal. So now let's see my mapping. So as you can see, so for example, if I have a website with the search functionality and my customer is searching for a category, let's say vegetables. Okay, so what it will do, first it will perform the analyzer on that particular query, and based on that, once this analyzer is applied, the query which is being formed in the backend. By query, I mean the Elasticsearch query. Once the analyzer has been has performed his action and query has been executed, the person will get the desired result accordingly. So just let me show you how this is actually working now. So let's say, um, okay, so let's say we have a product search, okay, where we are, so I am searching for vegetables category and I have typed all the characters in capitals. So this is how my in the backend my query is being formed. When I will search for it, as you can see, I will be getting this vegetables document. So you can see clearly, uh, to be more precise, so you will be like thinking how it's possible, how it's being done. So let me just show you how the analyzer works. So first, basically, analyzer works. So you can see I'm using the keyword lowercase analyzer, then the text, which is in my capitals. So let's run this. So yeah, as you can see, it generates a token in the smaller case. You can see. So in this way, analyzers can be helpful according to our requirements, like what kind of how we can make search more powerful, like how we can remove some bad characters from the query or lowercase the query or remove some extra white space, etc. So this was pretty much about analyzers. Now let's continue with our further topics. So let's explore more uh, Python code, how we can perform this thing. So as you can see, I am using an Elasticsearch DSL module in the Python. It's a high client package built over original Elasticsearch module. I'm using this module because it helps in abstracting away the complex ES queries. Also, it helps. So in this way, what happens is like the all the raw queries which are being written by the dev, it helps him to avoid the syntax errors and writing incorrect nested queries. So as you can see here, I am writing uh, like a, I'm searching for a product by its name, yellow and capsicum. So it will perform an analyzer of a stock word here. Uh, Let me just show you this one. So, okay, where is my mapping? Okay. So as you can see in product name, I'm using analyzer remove stock words analyzer. And now I am searching for yellow and capsicum. Let's see what happens. So let me first show you how this analyzer will work. As you can see, it will divide this text into two tokens and will remove the stock word and. So let's check this query, how it will be working. So as you can see, it returns the product yellow capsicum, and uh, yeah, like it's clear how it's the analyzer is performing really well. Okay, yeah. So scoring and search results retrieval. In this section, I will be covering how Elasticsearch is internally working and return search results based on user query. So let's say a user triggers a search from front end by searching a product name. We will be taking this example throughout the next slides to help you understand how internally our search is working in backend. So I will be also cover other topics like spell check, suggestions, and boosting Elasticsearch documents. So let's start with the spell check and suggestion feature. So suppose in our Elasticsearch, we have a document having details of various vegetables and the category in which these products are present are by name vegetables. Now, Elasticsearch will return documents if exact category name is written. Now, let's assume if the user from the search side writes in query as vegetables with a double V in the starting. Elasticsearch will return zero results. This is because the spelling is completely incorrect. Uh, I will show this as a demo in the next once completing this slide. So it will be much more clear how it's actually working. So to enhance such search experience and overcome such issues, we can add some incorrect spelling mistakes, which will target only the same document. Here, you can see the two incorrect spellings have has been defined for uh, which the same document will be returned. So let me just go through the document, how it's working internally. So as you can see, just let me, sorry, happened by mistake. Okay, okay, got it. So suppose I have this query, get product. As you can see, I'm just searching for vegetables and I'm getting my documents which vegetables. Now let's add an extra spelling mistake here with double V. Let's search. So as you can see, we are getting zero hits here. So how we can improve this thing? So it's clearly simple. Uh, we can do it like this, where we can use suggest feature from Elasticsearch. I've created one category suggester, which will, and here I've defined incorrect text. It can be more than one also. And there is another category suggester for which if suppose the user just queries vegetable instead of vegetables, there is a difference of a single S at the end. So let's see how this works. So once this works, so you can see the suggest shows like another category suggest. So this basically shows like which document category field it's matching more. As you can see, the vegetable is matching vegetables document, and the category suggested is again matching the our dog vegetables. So in this way, using the suggesters, we can pick the correct text, and based on the correct text, we can recreate our query and then execute it through the Elasticsearch. So in this way, basically how the spell check and the suggestion feature of Elasticsearch is working here. Okay. So let's move forward. So this is a Python example of spell check and suggestion. The query which I had shown in the example can be written using the Elasticsearch DSL module. We can then add an extra query also and execute that query, which will run on these suggestions too. So this is the part, and it's pretty straightforward and kind of really easy as well. Okay, now this is the final part, I guess. So let's see how boosting of a product is happening. So there is a field in Elasticsearch document called underscore score. Let me show you how it looks. So if I search for vegetables and I do this, you can see I am getting some sort kind of score here. So this field I am talking about. So this score field, this field tells how much the query keyword matches the document in Elasticsearch. Boosting a specific product can be done by like changing value according to business requirements. Like for example, if I have a product with category by name snacks, now um, we can have and now I want to search for like products with category snacks. Now on the right you can see I'm querying snacks which are spicy. Okay, now I will be boosting those products which comes in both categories. That is, they are snacks and they are spicy. There can also be a condition like if we query snacks and spicy together, we we may get like by like Elasticsearch may return us something spicy, other thing as well, like kind it can be vegetable also. So I'm assigning some random score to it just to make sure I get the product which I want. So these random scores can also be assigned to each document by using inline scripts in Elasticsearch as well. But I'm not using any inline script, so it would be like I'm just keeping it pretty straightforward and on easier level so that everyone can understand what's happening. For boosting, we always write a raw form of query in Python and pass it by a search method of uh, Elasticsearch client. So there is no such client method, but we just uh, write raw queries of boosting in raw form only. Okay, so let me just show you the demo. I guess I'm running out of time. Just let me just see. So as you can see in this example, this is the boosting query. So I want to search for snacks which are spicy, and I will boost that particular product so that I get the nearest product matching. So let's search for it. Okay, so now I am getting my results. Here you can see I got snacks with product name spicy chips. Then I also got another snacks with sweet chips. Okay, but as you can see, this product score and this product score, it's uh, simply clear that this product score has been boosted here. Instead of returning, like you can see if the user searches for a particular thing, how the results will be getting to him. And the most closest one will be on the top, you can see. Yeah, this is pretty much about boosting a specific product uh, in Elasticsearch, using Elasticsearch. So let me conclude. So we are at the end now. So I've got a lot of things uh, and pretty much fast as well. So we learned about the strategies to sync our database with Elasticsearch using bulk indexing. Uh, Covered the role of custom mappings and analyzers. We saw that earlier how it can be helpful and for our use case in business requirements. How search can be enhanced by using Elasticsearch features like spell check suggestion, document score boosting, and you can also find the whole Pythonic code implementation of each and every slide in my Git repository if you want to deep dive more into it. Also, if you have any questions regarding the code suggestions or looking to contribute, you can reach me out on Slack, email, or LinkedIn. Yeah, I guess that's pretty much it. You can find me on the below social media platforms. That's all, folks. I hope you enjoyed my talk and learned something from it. Thank you, everyone.
Thank you, Harshit, for your presentation. It was really interesting, and thank you to our audience for listening. Um,
Yeah,
so,
yeah. So,
are there any questions?
yeah,
So I think we can find additional questions in Slack. So, and
okay. Yeah. If anyone has any questions, then they can just reach me out on Slack, and I will share the slides as well. So hope you all enjoyed my talk here at PyCon 2020.
Yeah, thank you.
Good.
Then we are finished and you can connect to the next presentation. Thank you. Goodbye.
Okay. Thank you. Bye
You
bye.
too.